Great, so the recording's underway. Thank you very much. All right. Well, I thought I'd just run, this began as something quite small and it's become something quite large, which is wonderful. I thought I'd run a few sessions this week on scientific writing. I think it's one of those things that not everybody enjoys. Some people love it. Some people probably don't like it so much. Some of us struggle with it. Nobody finds it incredibly easy, I don't think. And it's one of those skills in science that we don't always get into science because we love writing. Sometimes we discover as we get into science that writing's a critical part of doing science and communicating it with others. And for some of us, that comes harder than others. And I guess the kind of large number of people joining these workshops reflects that, the kind of desire to improve and the difficulty of scientific writing. There isn't a single easy recipe for scientific writing. If I could, I would give you a 12-point list, and if you learnt that list, you would then be a perfect writer. But of course, scientific writing doesn't work that way. So let's begin with a brief introduction. My name's Professor Richard Fuller. I'm an academic at the University of Queensland, based in Brisbane on the east coast of Australia. You can find out more about the work we do at our website, fullerlab.org, and also on our Facebook page there, facebook.com/fullerlab. So if you want to check out more of the work we've done, maybe critique some of our writing, please go ahead and do that on the website and Facebook page there. Let me just get my, sorry, just opening my chat window, make sure I don't miss anything. Great. Reach out on chat if you have urgent issues. Otherwise, use the hands up function and I will get those, I will go through those for questions that come up. So first of all, I'm a researcher. I want to sort of get this clear, you know, what kind of disciplines do I publish in typically? I work in a number of different areas across conservation science, ranging from some pretty ecological work through to some work focused on social science and the relationship between people and nature. So I've published across a big range of different disciplines, from the fairly hardcore social sciences right through the applied conservation science, right to some fairly pure ecological science. So I guess I've worked in a range of different disciplines and faced trying to construct scientific writing across a number of different disciplines. I don't write this stuff to boast. I write about it to tell you, you know, to let you know where I'm coming from with this. I've published around 150 scientific papers so far and been working in science for around 15 years. My PhD was awarded in 2003 from the University of Durham in the UK. I've reviewed papers for, well, it's a large number, more than 50 different journals, and reviewing papers is a great way of, you know, really being forced to evaluate somebody else's writing. And it's a great learning opportunity, I think, for those of us who are at that stage in our career, perhaps late PhD students, early postdoc and beyond. I'm an associate editor, or recently finished being an associate editor for Journal of Applied Ecology, which basically means I handled papers that were submitted to the journal and arranged reviews for them and decided, you know, what recommendation to make the editors around accepting and rejecting and revising those papers. Other kind of aspects of writing that we perhaps don't think about so much. I review lots of grant applications and promotion cases, for example. So there's a huge range of ways in which scientific writing is critically important. Grant writing is one of those that we often forget about until that stage in our career when we suddenly really need to get grants together and perhaps haven't thought about it much up until that point. And I work every day to improve my writing. I am by no means a perfect writer, and you shouldn't take me offering these sessions as me suggesting I'm some kind of guru who's perfect at writing. I'm absolutely not. And you can never become perfect at writing. Everybody learns all the time, every day, or at least, that's my advice to you, is to try to learn and improve your writing every single day, every time you sit down at the computer. Okay. So I want to begin with some general thoughts about communication in science. And before I get into this, I want to make clear that I'm offering 3 sessions this week. So today, Wednesday and Friday at the same time, 12 o'clock midday on each of those days. These sessions are, they contain content that flows from one session to the next. So please show up for each of those 3 sessions. If you can only manage one, hopefully you'll still get something useful. Okay, so a few general thoughts, first of all, about communicating science. The way we communicate science, why do we need to communicate so much when we do science? A lot of us got into science because we love the science of it, answering the questions, discovering new things about the world. But of course, there's this realization that we need to communicate that to a range of different audiences. Take the discovery of DNA, or the structure of DNA. A massive discovery that, unless this is communicated to other people who can use that and who can capitalize on that and move forward to use that discovery. And this begs some very basic questions in, how does discovery and progress happen in science? Well, I guess we begin with an existing state of knowledge. So there's an existing pool of knowledge that's out there in the scientific literature. You then might make a discovery. So you discover something new. And that's the buzz and the joy that I think we all get out of science, is that moment of discovery. And the time that you put up your graph for the first time and you see a pattern that no one else has seen before, that enormous buzz that we get in science, that discovery, you found something new that adds something to the overall body of knowledge that's out there. You've made a discovery. It could be a big discovery or a small discovery, but all discoveries are exciting and I think addictive, and is one of the reasons that many of us stay in science for our lifetimes. Now, the discovery that you've made may lead you to new questions, especially if it's a bigger discovery. It might lead to a whole range of new questions or tests or ideas that are thrown up by that discovery that you then want to progress. So you might ask one of those new questions and make a new discovery, another discovery somewhere further down the line that adds to your existing state of knowledge. And broadly speaking, this is how science progresses. But so far, we've just been thinking about you, your discovery, a new question you asked as a result of your discovery, and then how you might work on something else as a result of that. But there's 7 billion other people in the world as well. Not all of them are scientists, of course, but a huge number of them are. The chances are that an important discovery will be made by somebody else. And unless you know about that discovery, you're not going to be able to incorporate that into your understanding of the state of knowledge or to generate new ideas that you can use in science. So when the structure of DNA was worked out for the first time all those years ago in the 1950s, one of the first things that the authors did was write a paper about it. They wanted to tell people about their discovery. Making that discovery known enables people to use it. and how many questions and new ideas and new hypotheses arose from that. Of course, many thousands or probably millions came from that particular piece of discovery. And the reason, the vehicle, the conduit between the discovery itself and its value to society was the scientific paper. The piece of scientific writing that communicated that discovery to the rest of the world, to other scientists who could use it. So publishing has become a critical part of communicating within the scientific community, in spreading knowledge and spreading news about discoveries that we've made around the place. And many people would argue, and some people are fearful of the fact that publication really has become central in evaluating the careers and successes or otherwise of scientists. And some of this has become known as the kind of publish or perish phenomenon. And perhaps some of you have signed up or come along to these sessions this week with this fear in the back of your mind. I've got to publish at some terrifying rate, or I'm not going to make fast progress in my career. And I'm not here to deliver a great sermon on the whole idea of publish or perish, but I will, of course, confirm something you already know. It's very real. Now, this is not something, I didn't write these words in front of us here. These are words that came across my desk as part of a grant application that I was involved with many years ago. But it shows you, as you read through this, the kind of way in which us as scientists have to talk about our scientific writing. It seems boastful, but this is the way that scientists judge each other, rightly or wrongly. Many people say wrongly, but this is the kind of metric that's commonly used. And you can, if you look at this, you can see a number of important themes that we're going to be covering in these 3 sessions this week. You'll see a theme around quantity. I published 389 papers, right? That's the lead off of this particular paragraph. I'm someone who publishes high quantities of scientific literature and scientific papers. You could then see calls out to particular journals, emphasizing quality, papers in Nature, papers in Science, PNAS, PLOS Biology. These are the biggest journals that one can hope to publish in. Nature and Science, of course, are published across all kinds of science. So these are the very highest impact or highest quality journals that people can hope to publish in. So emphasizing quantity and emphasizing quality. And last sentence down there, you'll see there's a call to how many times the work has been cited. And this is interesting and perhaps something we don't always think about as we're beginning our scientific careers. Publishing the work is really only the first step. What happens after that? Do people read your work? Are people going to cite your work? Does it develop new ideas and new questions in that way that we thought about just a little bit earlier? Is your work actually being used? You can write a paper and get it published, but if it's not used, then was it really worthwhile? Was it a good piece of work? Of course, papers can be cited for the wrong reasons too, but by and large, papers that attract a lot of citations are those that do their job well, that communicate a good and important discovery, but that also do that communication in a very clear and in a very compelling and memorable way. So this person's talked about how many times their work has been cited and what their H index is. The H index of 57 means that their 57th most highly cited paper has been cited at least 57 times. So your H index is a very difficult measure to increase. and requires a deep level of citations, and many of your papers being cited many, many times. Okay. So let's think about the scientific writing, the publication phase. As I've said, many of us got into science because we loved the discovery. And perhaps when you first begin science and you make a discovery for the first time, you think, well, that's it. I'm complete as a person. That's it. That's brilliant. I've done it. I've made a discovery. I've found something new that no one else knew about before. And there's just nothing like that moment. It's really exciting. So you get excited. Typically then, you choose the highest profile journal you can possibly think of. You're so excited. You think of a high impact journal. Everybody wants to know about my discovery. I'm excited. I want everyone else to be excited as well. So you choose the highest profile journal you can think of. You submit the paper. Now, what happens next has a probability attached to the outcomes that are possible at this moment. With a roughly 0.1 probability, particularly in the higher impact journals, something good might happen. Your paper gets accepted and you run up and down the corridor screaming, and your day is made, perhaps your career is made, and you're super happy. With a roughly 0.9 probability, your paper is rejected. You revise your paper, you downgrade your journal choice, and you try again. And in many ways, the game of scientific publishing is something like a giant game of snakes and ladders, with successive waves of optimism driving you up those ladders on the left, and all too frequent disappointments causing you to revise your journal choice, degrade, and try again. This is something like the game of scientific publishing. And also at this point, it's worth emphasizing there's a strong emotional side to all of this as well. You were excited about your discovery, you worked hard for it, and somebody else has told you it's actually not that exciting and not that interesting. And that's deeply challenging and can be very difficult for us to deal with. And we'll be talking a bit about some of that side of publishing and writing in a moment. So you submit the paper and you try all over again. So there's a brief introduction to scientific publishing, scientific communication. We could do massive long sessions on all of these individual topics. Here's a book I've enjoyed. I have no connection to this book or the author. I don't know the author. I have no benefit in recommending this. This is a book that I have found incredibly useful. And those people in my lab get a copy of this book. If there's anyone listening who hasn't got one in my lab, then get in touch. I give everyone who joins my lab a copy of this book because I think it's so important, and that we think about scientific writing. And this book goes through a lot of detail, a lot of technical stuff, but also gets across that real purpose. What are we writing for? And what are some of the important sort of tips and tricks? So this is a useful one. There are many others. You know, look around, read reviews. You know, there'll be books that you might connect well with, and those that others may connect well with may be different. So have a look around for support. Don't just use websites and chat forums and so on. You know, try and look for people who've really written these books from a career writer perspective, people who've actually done lots of scientific writing, done lots of publishing. You know, those are the people who've written books, I think, that can be really useful for us. So have a go at that. Scientific writing is very, very, particular, and there are real challenges and pitfalls around it. So that's one book that I recommend. A couple more general points before we get into the more detailed parts of these sessions. And relating to what I talked about just now, and I think this issue is actually at the heart of a lot of the reasons why many of us struggle with scientific writing. Science is an incredibly critical, scientists are incredibly critical of each other. And often that criticism is not just in private, it kind of happens in public, right? Or at least in semi-public settings. We review each other's papers, we write our opinions about those papers, we write our recommendations as to whether those papers should be accepted or rejected. And if we want to recommend that a paper is rejected, we have to say why. This involves criticism. This involves scientists criticizing and judging each other. And the fact that our papers and our writing gets judged and may be judged harshly is terrifying. And I remember as a PhD student suffering some of that judgment. My first ever scientific paper that I wrote got rejected 5 times in succession from 5 different journals. Now that almost completely derailed my career in science. I'm glad it didn't, because I've enjoyed doing science as a career. I'm glad I stuck with it, but I can tell you it was borderline. It's very difficult to deal with, or at least for some of us, I think many of us, to deal with criticism and rejection that comes as an inevitable part of the scientific writing and publishing exercise. So if you go into the office of many a professor, not that you will be right now, but in normal times, you may look in the corner of their office and see a box of tissues. And that's not because professors necessarily spend lots of time crying in the corner when they're in their office, but perhaps sometimes, occasionally, every now and then, somebody gets a rejection letter from a journal that is hard to deal with, emotionally difficult to deal with. Scientists are often not the most tactful of people, and there are some scientists in the game who are downright rude, right? And overly critical and unfairly critical and personal when they review scientific writing and scientific papers. This is an unfortunate fact. Many of us are working hard, of course, to try to turn that situation around, to try to be better role models and participants in this game, but it is difficult. Here are some of the reviews. These are actual quotes from actual reviewers of papers that I have written over the years. So let's just have a look at some of these and think about the emotional impact that some of these words can have on others. And I want you to realize that I'm still here, I'm still happy, I'm still standing. One can get through these kinds of things, but there's no question they are difficult to deal with. And I want to cover these sorts of issues first before we get into the more technical aspects of writing. This paper by Fuller confuses many issues and ignores huge swathes of pertinent literature. I'm not persuaded that Fuller et al. Are the correct people to be writing this. Think about that. How far away from a proper scientific review are words like that? And how psychologically damaging can words like that be to other people? The methods and data here are fundamentally flawed and the paper should be rejected. Well, at least that comment is about the science itself. One could argue that is a much more useful comment. Even if the analysis were done with proper data sets, I do not believe the results are really all that interesting. Wow, ouch. Hard to deal with. We can laugh, hopefully you're laughing at these now. Of course, when one's a PhD student and anxiously opening the decision letter from an editor, this kind of thing can crush a person. There's no question about that. So I think for those of you who are reviewing papers, please think really carefully about this issue. And let's I'm not saying roll back on your criticism. If you want to criticize a paper, go right ahead and criticize the work and the paper as needed, but do that criticism in a constructive and kind and gentle way. We're human beings at the end of this, and we need to treat each other so. I would add that all of these papers ended up being published, in fact, in the journals that these reviews came from. So another point is that reviews like this don't even necessarily indicate a paper that is ultimately going to be rejected. Sorry, it's cold up here. Okay, so we do live, science does operate in a very judgmental atmosphere, and part of our skill set is learning to cope emotionally with that. Even with a very kindly, well-written, gentle rejection letter, the basic problem is still there. You've been rejected, your work has been rejected, your paper has been rejected. There's no two ways about it. One thing we do in our lab is we openly talk about rejections that we've had. Each lab meeting that we have, we go through our papers, we talk about, we celebrate acceptances, we commiserate rejections, and we talk about those with each other. And being open and talking about rejection, as well as the exciting things that happen and the good things that happen, I think is useful. Everybody goes through it, all of us do, and we can support each other through those difficult times. All right, it's been a bit negative at the start, but importantly, I wanted to go through that emotional side of this. I think it underpins a lot of the fear and some of the challenge that many of us feel around scientific writing. So let's flip to the other side of all this. What's the best part of research? And usually I ask this question as an open question to the audience. I won't do that today because it's going to be a little bit tricky. Yeah. There was a survey recently that estimated 90% of scientists don't enjoy writing, and I can believe that statistic. 90% of scientists don't enjoy writing. And I think many of us got into science not because we enjoy writing, but almost perhaps because perhaps we don't enjoy writing that much, and science is a different kind of exercise and more about the discovery and the activity of science itself. So many scientists do not enjoy writing, and perhaps that comes across in the writing of 90% of scientists as well. Yet scientists, and as we've thought about with that Watson and Crick example, if you haven't written it, you basically haven't done it. If nobody else knows about it, your discovery, then it's not useful. It has to be discovered again by someone else who will write about it before it becomes part of the scientific body of knowledge. So in a very real sense, you haven't actually done the science if you haven't written it up and published it. And you could take that a step further. If you've written it, but no one reads it, you still haven't done it. So it comes back to that citation question. Nobody's actually reading it. Have you really done your job as a scientist in communicating your work? So Gloretta has her hand up. Would you like to ask a question at all? Feel free to unmute and ask a question.
Hi, yeah, great so far. The big question I had, and I put that in the chat, but the Watson and Crick paper is I feel that when I'm writing now, I spend more time on my introduction in the background than I do on my science. And if you look at their paper, it was 1 page long because they had one paragraph like, yeah, this is what everybody else did before us, but this is what's critical. So how do I time manage that?
It's a great question. I think some of that's going to depend on the journal, right? I think for some journals, of course, times have changed a lot since that paper. For some journals, Nature and Science being some of them, you're into that discovery pretty quick, I think. In other papers, the social sciences in particular, giving full and fair and thorough treatment of everything that's gone before is considered incredibly important in many social science disciplines. And in many of the ecological or biological sciences often fall somewhere in between. So I think the answer to that question is that it really depends on the journal one's targeting. And I guess my general advice is don't take too long to get to the punchline in the introductory. We'll talk about this a bit more in the depth of these sessions when we get into structuring papers. My advice for introductions is don't make the reader wait till the very end of it before you tell them the sort of what you're going to be doing and almost hinting at what the discovery of your paper is. I think with a well-crafted paper, it should almost be obvious what your discovery was right from the title, right? So in many ways, I think one can hint at and start to introduce the discovery itself very early in a paper, really leading right from the title itself. Do you want to follow that up, or should we move on?
No, that's really helpful. Thank you.
Great, thanks. And we'll come back to that issue. It's a really great question, and we'll come back to that in a bit more depth in the next session. Great, thanks. Okay, so the point here about the emphasis on people reading it. And this reveals a kind of second agenda behind what scientific writing is about. We've got to describe our discovery, but we've got to describe our discovery in a way that is compelling and in a way that gets people reading it and gets people remembering it. And finally, if you've written it, people read it, but don't understand it, you still haven't done it. So if your writing is bad, people find it hard to understand or boring and they don't get through it, then you essentially still haven't achieved that goal of scientific writing, which is really getting into the minds of other people. Which is why I love the subtitle of that book that I recommended earlier, Scientific Writing is Thinking in Words. Okay. So here's an approximate program for the activities we're going to follow in these sessions. Some activities, but they're very, very brief. I just wanted to list out a few questions that you would like answered or things you want to know, and we'll then basically have 3 kind of sessions through which I'll talk through various components. So mainly this will be me just talking from here, but I would really like people to put your hand up and interrupt as needed as we go along through these sessions. So that's a rough program. Now, we have a quick activity. It's going to take literally about 4 or 5 minutes, and that's all I really would like it to be. I'd like you to visit this Google Doc link, which I'm pasting into the chat. Please visit this Google Doc link and add questions that you have into that document so we can do those. I normally get people to write up questions they have on post-it notes. This is the online equivalent of that. So please write questions in there. I'm not really going to interrupt this session now to wait for that, but I would like you to write your questions into that document, things you want to know. And then as we go through this week, I'll kind of collate those and make sure we get all of them answered through the session, okay? So some people may feel reluctant to speak up in these sessions when there's 200 people here. I hope you don't feel that way, because this is a non-threatening environment, and we're all here to learn, all of us, including me. But if you feel that you don't want to speak up, that's a good way of getting your question across. It's completely anonymous, so just feel free to write your questions there. I can see some utter chaos in there at the moment. That's fine. It will soon settle down, and please get your questions into that Google Doc. Thank you. I'll restart my screen share. Okay. And just to reiterate, they can be specific questions that you have. They can be general questions, emotional questions, technical questions, big or small, specific or general, just anything, things that you want to get from this workshop. Okay. So I want to begin by thinking about the writing itself. We've talked about a number of issues already, publishing and citations and whatever. I want to start talking first of all about the writing itself. And the first thing I want to do is let you into a secret that's possibly the worst kept secret of scientific writing. Good writing gets published. Good writing is out there for all of us to see. This is not some kind of secret society. There are millions of scientific papers out there for you to see, for you to read, for you to learn from. And if one's aiming for particular journals, it sounds obvious, but I think sometimes we don't always do it. Read the papers in those journals. And don't just read them, take them apart. Get some Nature papers in the topic of your choice that you're working on, and take those papers apart, line by line, sentence by sentence, paragraph by paragraph, word by word, and try to understand what it is that they did. How did they create such incredible writing? And I suppose underpinning that first point, I don't automatically assume that papers in Nature and Science are the best papers. We all know that's not necessarily the case. We all know that many of them suffer from replication problems and overhyping and so on. We know some of these things. But we can learn from the style and the writing of many of the papers that we think are the best in our discipline. Read the papers of the best people in your discipline. Try to understand and unpick their craft. How did they do it? What words did they choose? How did their narrative flow? How did they balance the technical aspects of showing you their discovery versus talking about why that discovery is important? How did they achieve such a high density of meaning and information with so few words that are so beautiful and pleasurable to read? So the first thing is to not bother attending writing workshops like this, but to actually simply read the great papers that are out there already in the scientific literature. And to re-emphasize, and sorry to repeat this, but I think it's probably the most important thing I'll say in these 3 sessions, don't just read them, analyze them. You're good at analysis, you're a scientist. Analyze these papers, understand why they are as good as they are. Look at the figures and tables, understand how they're communicating, try to figure it out. What is so good about those papers that has made them end up being such great pieces of work? Choose papers that you have enjoyed a lot and that you think, wow, I learned so much almost without feeling any effort on my part. That, I think, is one of the real secrets of great scientific writing. Communicating directly into someone else's mind without them having to go through enormous mental gymnastics and enormous amounts of effort and rereading your sentences to try and understand what you meant. Somehow transplanting your thinking directly into someone else's mind. For me, that is the hallmark of truly beautiful writing. So learn from papers that are well written. Choose the world's most famous scientists. Write a list of them in your discipline. Who are the 5 best scientists in your discipline? Read their papers. and use those as a guide. Don't use them as a way to self-flagellate. So, oh, I could never do this. We're all learning and we're all progressing as we go through our careers. Learning from the best has surely got to be really a top secret and the best trick. Analyse why their writing is so beautiful. And this will vary from discipline to discipline. There is no single recipe. There's no simple set of tricks. You have to unravel the beauty of the writing that is in the best papers in your discipline. Here's an activity. I'd like perhaps people to suggest in the chat some of the problems that this particular piece of writing has. Fire them into the chat. Paradigmatic, yeah, long sentences, totally. Absolutely full of scientific jargon. This is a real paper. And this is, I think, it's the worst example of scientific writing that I could find. We're all reasonably intelligent people. I think very few of us can understand any of this. It's like they're using the thesaurus function that somebody points out, trying to find a complicated word instead of an easy one. What is the point of all this? What topics? What is this about? That's right. There's no flow. There's no flow. There's just a jumble of words. Absolutely. So great points being made there. Really almost no logical flow between the sentences here. So we have lots of thoughts on that one. And of course, in many ways, it's easy to criticize bad writing. It's kind of harder to unlock the secrets of good writing. Really interesting point that somebody's put in here. We need lots of effort to put in. We have to make a huge amount of effort. I had to read a lot of these sentences multiple times, and really I still didn't have any idea afterwards. Someone has written it can't be understood, and maybe that's partly because of my poor English. Well, I can assure you it's not. This is not understandable. This is terrible writing, and good writing should communicate clearly to everybody. There is absolutely no need for scientific writing to be like this. This is writing that does not do its job. It does not communicate effectively. It's not big or clever to use lots of incredibly long words. These are poorly constructed sentences that do not enable understanding. So I can assure you this cannot be understood whether English is your first language or your seventh language. Okay. So that's a bit of fun, firing cannons at some bad writing. Let's try to unpick some of the hallmarks of good scientific writing. What are some of the general hints for scientific writing? And I think one of the things I've sort of begun to realise, I think, is before you start, stop. Have a think about what you're going to be writing about, or what you are writing about. If you're halfway through a paper and feeling a bit stuck, maybe just stop, put it down for a bit. Have a think about some of these questions. Why should a reader spend time with your paper instead of all the others they could read? There are hundreds or thousands of scientific papers coming out every year. and there's a lot of competition. There's a lot of noise. There's so much flow of opinion and writing and everything coming at us. Why should a reader spend time with your paper instead of a number of others they could read? And you might think, well, I don't really care if people read it. But actually, remember, this is the question that journal editors are asking when they're evaluating your paper. Will the readers of my journal actually want to read this paper? Do they want to know the thing that this paper discovers? Do my readers want to know that? Secondly, will my readers be excited and be able to read this paper and to get something out of it? Will they enjoy reading it and enjoy, therefore, my journal? Ask yourself, why are you really excited about what you've discovered? What excites you about it? When you got that buzz, why was that? How does what you've discovered move things forward in your field? Why is it exciting and new? What exactly is the discovery? Work out what you've discovered. That might sound a very strange thing to say. Sometimes it's not all that clear from some pieces of scientific writing. And I think that perhaps suggests that sometimes it's not that clear in our head what it is we've actually discovered. It may be worth trying to write out some simple phrases. In this paper, I blah, blah, blah. What do you do? What's the paper for? Or you could write, I have discovered ... What is it that you've discovered? What is it that's new? And I think it's really important that we know that. It sounds very basic. I think it's something that, unless we're very clear about, well, there's no way we can communicate it to other people. So perhaps the first thing for us to do is to communicate it with ourselves and make sure that we fully understand what our discovery is, why it's important, why it's exciting, what's new about it. And this will help you communicate that to someone else. If you're just trying to start writing about it, writing your methods and just trying to write your paper without really crystallizing in your own mind what you found and why it's important, it will be hard to convince the readers of your work that your discovery is important and exciting. And the writing that we just critiqued, it was kind of hard to work out even what the discovery was, right? Let alone why it's important. So really think these through. Make sure you understand it yourself, because if you don't, it'll be very hard to convince or help someone else to understand it. And I think this is often the cause of unclear papers, basically, where the author's not quite sure themselves what it is they've done, or perhaps not quite sure themselves why it's important or why it's new. Any questions on that? Please feel free to raise your hand. Okay. We have 5 more minutes, and I am going to finish at 1 o'clock, but then we'll continue on Wednesday. Secondly, and this relates to a number of the comments that came up in the chat, write to be understood, not to impress. Someone mentioned that the writers in that piece just now seem to use a thesaurus. In other words, try to find a complicated word when a simple word would have done. Perhaps they're trying to impress people with their knowledge of difficult and complicated words in the English language. Now, that is a barrier to understanding, right? If I have to pick up a dictionary to read a sentence, there's no way I'm going to enjoy reading that sentence, right? All of us are,
well-educated people, we understand lots of words, and there are thousands of simple words in the English language that can be used to express most of the concepts that we need to cover when we write our science. Sometimes we need to use particular words. Sometimes we need to verge on the jargon, but minimize that to the greatest possible extent. Don't write to impress other people, write them to help them understand you. This relates to what I was saying just now about making sure you've got your understanding in place. Then your job is to transfer your understanding into someone else's mind. Tear down the barriers that could get in the way between you passing that understanding to someone else. Don't try to impress them with flowery language or long words or complicated or long sentences. That doesn't impress them. All that does is create barriers. Good scientific writing is about great content. You have to have content. You need a great discovery. You need to know what that discovery is. I suggest trying to write in a way, in a style that has a high density of information, but is highly readable. And you might say that's impossible. It's absolutely not impossible. Look at some of the greatest papers in your discipline, in some of the highest impact journals, and you will see that. When you analyze some papers, and I really wanted to analyze one or two papers in your discipline, you will notice this, a high density of information while being highly readable. This is the heart, I think, of the conundrum or the sort of conflict of achieving great scientific writing. Lots of information giving rise to a nuanced understanding in the reader's mind, but with highly readable text. It can be done, and we'll come back at various points in these sessions to talk about how. But the best place to start is by you looking at good examples. Write with the simplest possible words. It's the absolute, if there is a golden rule, it's this one. Use a simple word use the simplest word possible for every concept. The simplest word possible. Not the most complicated word possible. No one enjoys complicated words. No one. They're just barriers. They're barriers to understanding. They're barriers to people who don't have English as their first language. It doesn't help anybody. Use the simplest possible words. We don't want the words to get in the way of understanding the scientific concepts. It's the science we're trying to communicate, not our knowledge of the English language. Simple words, put the focus away from your words and onto your story, and onto your meaning, and onto your science. That is where the focus should be, not on that. Well, someone's mentioned I've been dropping out. I hope that hasn't been too problematic. All right. Okay. Sorry, I'm just looking at my internet. Well, the time is coming up. It's 1 o'clock. So I think I'm actually going to stop here, and we'll come back on Wednesday for the next session in this. I'll try to make sure my connection is stronger. I apologise if that's been a little bit too weak today. Come back Wednesday at 12. We'll continue going through the material that I've got, and then we'll also push that forward on Friday as well. So thank you all very much for joining today. Please add your questions and topics into the Google sheet, and I will look at those. And if necessary, we'll do a number more sessions until we have all of these answered and gone through. Another question from Greta. Thank you. Sorry, I'm probably getting your name wrong.
That's okay. It's Gloita. Do you know of any journal clubs? I put this in the chat, but this is something I miss coming from the US to Australia, are the journal club and just sitting and talking about papers. Are there things like that on the campus that I've just missed, or do they not exist so much?
Others may know, and if you have a response, please jump in. There's not that many general things, I don't think, that would be useful to people in particular disciplines. Perhaps it's something we should be thinking about. You know, maybe even these could turn into something like that over time. Often individual labs and small groups of labs will do journal club type things, but it basically varies really from lab to lab. Yeah, so I don't really know of anything, unfortunately. If anyone has anything else to add, please do.
Yeah, I was just looking at the number of participants today, and I thought, you know, just with what a way for people just to bring their papers in, or especially the rejections. I've never seen anybody share their rejections, so that was very useful to me as having been rejected. That was nice. Oh yeah, it's not just me. So thank you for that. Yeah,
it's no problem. I do think we don't often, well, it is good to share experiences. Publishing is very difficult, and it's very difficult, and it can be very emotionally sort of confronting at certain points. And you know, we're not often as good as talking about that as we should. I think often we think, oh well, you know, we're scientists, we're supposed to be dispassionate and so on, and we can find it hard to do that. Sharing experiences can be very powerful, and just getting together as a group of people, just do it yourself, if you like. Get together as a small group of your PhDs and postdocs in the labs around you, and just do that. Even just sharing your experiences about papers. I mean, that might be a good thing to do with a few colleagues.
Thanks. I'm just putting my email over in the chat box because a couple of people said they'd like to do something like that. So I'll just share my email out so people can email me.
Awesome, great. Happy to take any more. I'm going